Aloha, everybody. I wanted to do a little bit of prep for you for the lab activity that I'm going to have you do. While we're not in class, I still want you to understand what we would be doing if we were in class. And I'm going to do a little bit of give a little bit of an explanation for you regarding the virtual lab that you're going to do. So the virtual lab is essentially the same activity that we would do in class, but you're going to be doing it with a simulator. And so let me first start off by asking you a question. And that question is, what are the parts of a pendulum? Do you really even know what a pendulum is? Just kind of think about that for a second. There's some examples of pendulums that I think that you probably can come up with. Many of you as kids, or if you work at an elementary school, most schools still have swings on the playground. And so a swing is an example of a multiple rod or string pendulum. And then there's always things like a metronome, perhaps, which is essentially it's an inverted pendulum. Instead of swinging like this, it swings like that. And then, of course, I think that many of you maybe have relatives, have a tutu perhaps, or maybe an auntie that has a grandfather clock or a clock with a pendulum on it. There are some other examples too. But we're going to kind of limit ourselves to that. I will provide in the resource folder a little bit more, some links to some pendulums for you, some examples, because frankly, you're going to have to respond to that. So what I'm going to do first is take you to the setup for the activity that we would physically have done in class. If you had been here, you'd be working in pairs, ideally. Or maybe groups of 3 or 4, but ideally 2 people. You can do it individually, but it gets to be kind of a challenge because there's a lot of moving pieces. So what I'm going to do is I'm going to pin the video on the other computer, and what you're going to see is the setup. And so I'm going to talk, but I'm going to turn. And so what you're going to see is you have the rod, you have the point of the pivot, and then there's this empty space right here, which will be where we will hang the actual pendulum string. And so the pendulums are kind of interesting. I'm going to start with a long string, and so we're going to put the long string up on here, maybe. There we go. And I'm going to, and you'll notice it's kind of hard to see, but this is a fairly long string. I could take the ruler, and it's 30, approximately, it's about 50 centimeters long, so it's about 18 inches. Then what I'm going to be doing is we're going to, instead of using specifically known masses, we're going to make an assumption here that this mass and this mass and this mass all have the same or approximately the same mass. And I actually did put them on a electronic balance, and I found that they were actually pretty close. So what we're going to do is we're going to put, this is going to be the basic setup. And so what we have here is we have a basic pendulum. So with the pendulum, there are 3 variables. There is the plumb bob, and plumb is plumbium for our lead. In this case, it's not, but that's why it's called a plumb bob. In this case, we have a washer. We'll call it mass 1, or a mass of 1. And then we have the length of the pendulum. And then you're going to release the pendulum from a specific position. So you're going to have, and we would use, ideally, you would use a protractor to get an idea of the angle, or you could simply take a ruler and you could measure, probably be best to do like this. You could start it at 10, 15, and 20. So that's going to be low, medium, and high. You never want to drop a pendulum from much higher than about 75 degrees because it just drops, gravity pulls it down. And so gravity is also a variable, as is friction. In this case, the friction and the gravity are constant, pretty much, so we're not going to really worry about it. And so how do you actually time this? Well, you're going to be timing the period of a pendulum. The period of a pendulum is the time that it takes to go from the point of release across back to the point of release. So you're going to measure that in essence in seconds. Your reaction time, which is about 0.2 seconds, is so slow relatively that you'd never be able to get consistent measurements on one. So ideally what you're going to be doing is you would, at least if you were doing this in a face-to-face environment, is you would let it swing 10 times. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, and stop at 10. You would get that time in seconds, divide by 10, and that would give you your average for the period of a pendulum, period being one swing. You do that a couple of times because consistency is really important in science. So the variables are the weight, the mass, the string, and the height. And so I started it at a fairly low height. It started at a higher height and even a higher height, but you never want to go much over about 30 degrees. And we can add weights to it. So what you would do in class is that you would change one variable at a time. So that means that once I've taken the data with one weight, a long string, and always releasing it at the same point, I could get data by adding a second mass. And so the question then becomes, and this is the question that you would ask your students, will the pendulum's period be impacted by the weight, changing the weight? Is it impacted by changing this length or by changing the height of release? And those are the three variables. Those are the three variables that you'll be studying in the virtual lab. And so I'm not going to use this setup because you will not have this setup. You could set this up at home with your own materials, but in this case, what we're going to be doing is now talking about how to do the virtual lab. So I'm going to go ahead and repin my other computer here, pin this, and I'm going to share the screen. There's a couple of different things on this screen, so there might be a couple of little lags, but ideally what I want to do is I want to share the screen, and we're going to be looking at this activity right here, and you should be able to see this activity. What we've got here is the ability to annotate. And so what I'm going to do is I'm going to draw, and I'm going to use a little squiggle. Let's see what we get here. Oh, good. That's perfect. All right. So that's not good. I'm going to unannotate. Okay. Now, I should be able to move that. Yep. Okay. So I'm going to ignore the little blue marks there because I can actually use the annotate feature within the PDF. There is a website that you'll be going to, and we'll be taking a look at that in just a minute. But basically, I want you to create a list of your variables. We've talked about that a little bit. You might want to go back and look at the video if you missed out on what it was we were talking about, or you can physically move ahead to the lab itself, and you should be able to figure out what they are. But in this case, we're really looking at three different variables. If you are familiar with Newton's three laws, this should be pretty straightforward. If you're not, I would encourage you to look them up. You can Google it, but I think that you'll find that there's some relationship between the motions of a pendulum and the 3 laws of motion. Then there's some directions on how to set up the simulation, which we'll talk about in just a minute. And there'll be some questions on data table 1, record the period pendulum for each trial. Be sure to calculate average period for each data set. It's pretty straightforward. Construct 3 new pendulums, test hypothesis formulated in step 6. In this case, you can change gravity or friction as variables. Just remember to only change one variable time. So there's going to be another data table. Then you can analyze your new data, and then you'll be able to actually respond to some questions. Next generation, how does this incorporate next generation standards for your grade range, and so on and so forth. You can draw. When you get your data, you'll be able to plot your data, whatever it happens to be. It might be something like this, and you're going to have your period in seconds, and so you might have 1 second, 1.2 seconds, 1.4 seconds, so on and so forth. So I don't know exactly what you're going to have at this point, but let's just say that you don't need to get too stressed about these times. We'll be able to figure it out in a little bit of time. Okay, so there's some information about pendulums there, and then here's your data table. So I'm going to be taking you to the pendulum lab real quick, and I'm going to take you to the PhET site. It's called PhET. And you should be able to see that. Okay. So you have a couple of options here. You can download it onto your computer. You can embed it if you want to put it in social media, which I don't think you want to. But the idea is to click on that site. There's an intro, talks about how to use it. There'll be information about energy. Or you can go to the lab itself. You click on it. It makes that icon a little bit bigger. Click on that, and what we're going to do is we're going to take a look at this pretty quickly. I'm going to grab myself the directions, and so what we have right here is we're going to be clicking on the period timer. You can leave this period timer wherever you want. I just kind of like to put it over here because for me it just works. So let's take a look at what we have here. We have the parts of it. You have the length. The length goes from roughly 10 centimeters or 0.1 meters up to 1 meter or 100 centimeters. The mass goes from 10 grams up to 1,500 grams. So that's 100 grams to 1,500 grams. It's currently at 1 kilogram, which we can, in this simulation, we can say that's equal to 1 washer, or 2 washers probably would be better. Half of a kilogram would be 1 washer, and 1.5 would be 3. It really is not critical. That would be a pretty heavy washer, but the whole point is that you're going to be using 1. In the first activity, we're going to go with 0 friction, and we're going to have our gravity set at Earth because, hey, you know what? We live on Earth. You could change it to friction as long as you're consistent. It could be anywhere along here if you want, but particularly depending on the age of your students, if you're working with upper elementary kids, you know, you can start introducing the concept of gravity and how it's going to impact it. If you're doing high school kids, they are going to get gravity a little bit more. I mean, not that little kids don't get gravity. Gravity is intuitive, would make you fall down and scrape your knee. But ideally, what we're going to be doing is we're going to be taking a look at the data, and we're going to go to the data table, and I'm going to get this data table set for you for a minute. And so I'm going to share this back again, and just so that everybody can see it. So what we've got here is we've got a data table, and the data table is set up with some information already given. So for example, this says length in centimeters. That's 60 centimeters, which is 0.6. The mass is 0.5, which is half of a kilo. And the height in degrees, or that's the release point, is going to be 30. The length is still 60 or 0.6, 0.6, 0.6. So for pendulum 1, we're going to be holding the length constant at 60. The mass is going to be the variable we're going to be checking, and the height is going to be consistent at 30. So let's go ahead and take a look at the activity really quickly, and we're going to generate up a little bit of data. And so what we're going to do is we're going to take this mass and change that mass to 0.5 for the first one. We're going to change this to 0.6. So right now, the only thing that I haven't done is I haven't changed the height. Now, how you change the height is simply by moving it back and forth. I'm going to go to 30. That's 40. I'm going to go to 30. And when I release it, it'll swing. And then if I hit period, it'll take the time for one period. Then I can stop. So the time for one period is 1.5809. I'm going to clear that. I'm going to take this back up to 30. Let it swing again. And it's 1.5809 for my second trial. 1.5809, I'm going to stop it. I'm going to go back to 0, take it back up to 30, start it. So I've done this now 4 times. I've gotten 1.5809. I'm going to go ahead and go back to the data sheet, and I'm going to put in the amount, which was 1.5809. Then I'm going to go back to my lab, and we're going to change the variables. We're going to keep this length at 6.6. We're going to change this to 1 because that's what we're changing is the mass. And we'll zero this back out. I'm going to move this guy back up to 30 because that was where we're going to start, and we'll swing it. Well, I'll be darned. So I've got 1.5809. Let's zero it again. Take it up, release it. Hit stop. Clear that. Do it one more time. Getting pretty consistent. So we're going to go clear that out. I'm going to go back to the data table. I'm going to write in the time again, 1.5809. And now we'll go back to Pendulum Lab itself. I'm going to change this now to 1.5 because that was what the reference would be. I'm going to raise this up to 30, let it go. 1.5809, zero that out, go back up to 30. 1.5809, go back up to 30. 1.5809. Okay, so you could do it, I think 3 times for each trial is probably plenty. Now I'm going to go back to my worksheet. I'm going to put that data in. Again, I get 1.5809. So we're going to do an average. This was still 60. The average is 1 kilogram. 30 is still that number, and we're going to put that in. Now, I'm going to, for sake of argument, I'm going to just say that this is 1.58 1.58, 1.58, 1.58. All right, we don't need to have so many significant figures. All right, in this case, we're going to, the second case, we're going to be using stem length. We're going to keep the mass consistent at 1, and we're going to change the angle and see if there's anything that happens there. So let's see, we want to go back to the lab. We'll go back to the lab. We're going to make this guy 1. We're going to keep that 60. And this time we're going to change these. So in the first case, it's going to be at 15 degrees. And we'll let it swing. And that was 1.5606. Okay. So let me go do that one again, 1.506. 1.506. 1.50606. Okay, so it's really consistent at 1.5606. So we'll go back over and we'll put that data in. And so I get, this time I get 1.5606. All right, and we'll go back to, we'll call that 1.56. That's pretty good. We'll go back to the pendulum lab. I'm gonna clear this guy out. I'm gonna raise this to 30. Release. 1.5809. 1.5809. 1.5809. Well, that's pretty consistent. So 1.5. Go back over here. 1.5. Oops. 1.5809. 1.58. All right, and the next one we're going to go ahead and get set at 45. And we'll set this guy back to 0, go up to 45, and let go of it. Okay, 1.61. All right, back up to 45. 1.61. 1.61. Okay, so we'll go back here. 1.6. 1.60. 1.62. All right, so now I'm going to actually have to get out my phone or my calculator. You guys probably use your phone. So I got 1.56 plus 1.58 plus 1.62 equals 4.76 divided by 3 is, my average is 1.76. 1.5867. So that's 1.59. All right. Well, 1.59 for an average is pretty close to 1.58. So what I'm not seeing is a whole lot of variation between these two. So what I'm going to let you do now, you're going to keep the mass at 1, and now you're going to be changing the length to 30, then back to 60, and then out to 90. And you're going to be determining if the length has a greater impact on the period than the other two variables. Once you've completed this activity, oops, let me go back here. Sorry about that. So in this case, you're going to be just changing the length, 30, 60, and 90. And you're going to be keeping the mass at 1. And you're going to be dropping it in each case from 30 degrees. So it should be pretty straightforward. And you're going to be looking at if the length is the primary driver for the period of a pendulum. Okay, then in the next section, you'll be looking at some other variables. And so in the next data set, you'll notice that you have gravity and friction. Remember, it's really important that you only change one variable at a time. So if you're changing gravity, only change gravity, keep the length, the mass, and the height, and the friction constant. If you're changing friction, keep the length, the mass, the height, and the gravity constant. There's 3 different, you've got, like, friction can be none, middle, a lot, however you want to do it. Gravity can be, you know, like, gravity is, you got choices here. You got moon, Earth, Jupiter, planet X, or custom. So you can just pick 3. It's not a big problem. So, all right. So without further ado, I'm going to stop sharing the screen. And what I want you to do is to work on the virtual lab, complete the data sheet, and there will also be an NSTA Learning Center for you to work on that's going to be dealing with an article or maybe 2. So I hope that you found this activity, or you find this activity engaging, and it's not real hard, but if you get real interested in it, make your own pendulums and try them out and see if you get more variation. All right, that's it for today. I'm looking forward to working with you guys. Probably next week, we're going to be doing some activities that require materials. I'm going to put those together this week so that they'll be ready for you to pick up on Monday, a week from now. So you guys have a great one, and we'll talk to you later. Bye-bye.